And coming to the bitwise operators, as the name implies, these operators will perform the operation bitwise. For the given value, it will take the binary equivalent and it will perform the operation bit by bit. Okay, and here is the truth table for binary AND, binary OR, binary XOR. And this is binary ones complement. Ones complement is very easy. That is, if the input is 0, output is 1. Input is 1, output is 0. Okay, so for these three things, we have a truth table here. Two variables are there, P and Q. Binary AND operation. So as we know, AND operation will provide the output true only when all the inputs are true. Okay, so here we have two variables P and Q. So when we have two variables, four conditions are there, four possibilities are there, 0 0 0 1 1 0 1 1. So AND operator will provide the output 1 only when these two inputs are 1. So for 1 1 case only output is 1, for the other cases output is 0. But whereas OR, as the name implies, when either one of the input is 1, output is 1. So here the first condition 0 0. For this case alone output is 0. For the other cases any one of the input is 1. Any one or both are 1, the output is 1. Right. Then exclusive OR. Exclusive OR, the function is actually P Q bar plus P bar Q. This is the Boolean expression for exclusive OR. But to simply understand the function of exclusive OR, you can have a thumb rule like this. When both the inputs are same, output is 0. That is, when the inputs 0 0 and for 1 1. For 0 0 and 1 1, output is 0. That is, for similar inputs, output is 0. For dissimilar inputs, output is 1. So keeping this in mind, we can work out some other examples. So let us assume A is equal to 21 and B is equal to 64. So as we know, bitwise operators will perform the operation bitwise. Okay. So it will first have the binary form of the given number. For 21, this is the binary form. 64, this is the binary form. Okay, A and B. So now it will perform binary AND operation bitwise. So you see here, data 1, data 2. 1.0, 0. 0.0, 0. 1.0, 0. That is, when both the inputs are 1, the output is 1, otherwise 0. Here actually in our example, both ones are not available, so all the locations are 0. Alright, so the output is 0. Then A or B. A or B. When any one of the inputs is 1, output is 1. So here one is there, 1 plus 0, 0 plus 0, 0. When both are 0 only, output is 0. Otherwise, the output is 1. So this is the output and equivalent value is 84. Then A exclusive. You know that when the inputs are dissimilar, output is 1. When the inputs are similar, output is 0. And binary negation or ones complement. When the input is 0, output is 1. When the input is 1, output is 0. Just complement of each bit. We get this one and the answer is 2. And coming to the shift left and the shift right operators. Okay. So this is binary left shift operator and binary right shift operator. That means the binary left shift operator will shift the contents of the input left by one location. You see here, all these bits are shifted left by one location. So what will happen? This 0 will come here, this 0 will come to this location, 1 will come to this location, so that ultimately the leftmost bit will be dropped. Okay. because all the bits are shifted left by one bit. So what will happen? This will become 0 will be dropped. This 0 will be dropped. So that the remaining values are 0, 0, 1, 0, 1, 0, 1, and finally we have to add 0. Finally it will add 0. Suppose if we give 2 here, a less than 2 means the content of a will be shifted left by 2 times. So in that case what will happen? The leftmost 2 digits will be dropped out. So it will start from 0, 1, 0, 1, 0, 1, and it will append 2 zeros. That is going to be the answer. Okay, similarly for any number of shift right, answer is 4, 2. Shift right, it will shift the content of A right by 1 bit if it is 1 here. If it is 2, it will shift the content of A right by 2 times. The same thing will happen here. For this example, A greater than 1, right? So this one will be dropped. This one will be dropped, and these 7 bits will be shifted right. And in the leftmost location, it will add 0, right? So likewise, you can take some more examples and try yourself to understand better. Then coming to the relational operators, these operators are used to compare two operands to take decision, right? So double equal to means check for equality, because we know that in C language a single equal to is used for assignment, that we'll see later. Double equal to is used to check for equality, right? Then exclamatory followed by equal to is not equal to, then greater than, less than, greater than, equal to, less than or equal to. These are all the relational operators. See the example say, let us assume A is equal to 10, B is equal to 20. For this case, if we go for this condition, A equal to B, that is 10 is equal to B. This is not true. Okay. And both the values are same, this will be true. Right. Now for this example, this is false. That is, it is not true. Then A is not is equal to B. That is so. So it is true. A is greater than B. False. That is not true. A less than B. True. A is greater or equal to B. Not true. Less than or equal to B. True. Right? Then assignment operators. So the assignment operator is equal to. Equal to symbol is the assignment operator. This is used to assign the value from right hand side to left hand side. Example is C is equal to A plus B. What will happen? It will perform or it will evaluate A plus B, and this value will be assigned to the variable C. Right. And also we can combine the arithmetic operators and binary bitwise operators together with the assignment operator, as you can see here. That is, we can affix any arithmetic operators or bitwise operators in front of the equal to symbol. These are called as the shorthand operators. Shorthand operators. Look at the example. C plus is equal to A. C plus is equal to A. That means C is equal to C plus A. So it's a C is equal to C plus A. Normally we will be writing. This can be written as C plus is equal to A. This is a shorthand operator. Similarly, we can use shorthand operators like this. You can see the example for those things. Right. That is, the operator should be affixed in front of the equal to symbol. So instead of repeating the variable twice, instead of repeating the variable once more, we can go for the shorthand operator, as you can see here. See here, C divide is equal to A means what? C is equal to C division. The same thing, same phenomena applies for all other operators. Then conditional operator, which is also called as a ternary operator. So far we have seen unary operator, binary operator. Unary operator involves single operand, binary operator involves two operands. Here it is ternary operator. So ultimately we can understand that this involves three operands. Okay, so the symbol is question mark followed by colon. The syntax of this conditional operator is condition question mark expression if true colon expression if false. So you can see here three operands are there 1, 2, 3. So 3 means that is ternary operator, right? So let us look at the example. Example 1, a is equal to 5, b is equal to 6. You see here c is equal to a less than b question mark 1 colon 0. So the first one is the condition. If the condition is satisfied, what will happen? This conditional operator will assign the operand 2, that is expression if true. Here it may be a single value or it may be an expression. Okay, here in this example 1 is given. So since the condition is satisfied here, that is 5 less than 6, this 1 will be assigned to the variable c. That's what we have seen here. Example 2, a is 5, b is 6. Okay, the condition is satisfied again. You see here instead of 1 I have given a plus b, or any other expression can also be given. So this will evaluate this expression and this will be assigned to the left hand side variable. So a plus b, a plus 6, 11 is assigned to c. Example 3, a 6, b 5. Condition is not satisfied here. So that what will happen? It will assign the expression or operand 3 when the condition is false. So here the condition is false, so that it will assign the third operand or the expression if false, that is a minus b in this example. A is 5, b is 6. So sorry, a is 6, b is 5. So the answer is 1. So a minus b will be assigned to c. So 6 minus 5, 1 will be assigned to c. Got it? Fine. Now the miscellaneous operators. We have brackets, square bracket, parenthesis, dot, hyphen followed by greater than symbol, and star size of type. So this brackets operator is a function call operator. We used to call the function. Brackets is used for array subscript. Parenthesis is used to group the set of statements. This can be used in control structures or in function body. Dot operator and this one, all these things are used in the pointers. Okay, pointers. Then size of operator will provide us the number of bytes of the data type. For example, size of int will provide 2 because it occupies 2 bytes. Size of float will give us 4, that is it will occupy 4 bytes. Size of double, the double data type will occupy 8 bytes, it will provide 8 like that. Then the type operator, this is the cast operator. So this will convert the data type from one to another. If you want to convert an integer to floating point or floating point to integer or whatever, we can go for this. Okay, for example, I have the floating point value say 2.5. Okay, I want to convert that into integer. So what I can do, I can use the statement within brackets int followed by 2.5. So what will happen? 2.5 is the floating point value, but the type I have given is int. So the floating point value 2.5 will be converted into integer type. So it will provide only 2.